Okay, so this is problem 11.1.63, and it says the digits 3, 4, 5, 6, and 7 are randomly arranged to form a 3-digit number, and they're telling us that digits are not repeated, and they want us to find the probability that the number is even and greater than 700. Okay. Okay, so first thing you're always thinking about in these types of problems is, am I dealing with just a counting problem or am I dealing with a probability problem? And since it's asking us to find the probability, we know we're going to be dealing with a fraction. So we're going to have our desired number of outcomes over our total number of outcomes. Okay, so that's our probability fraction. Okay, so the best way to think about this is to just start with the limitations. So you have a 3-digit number, and you can choose from 3, 4, 5, 6, and 7, and we don't want to repeat digits. Okay, the two stipulations that they give for us is that this needs to be even, and it needs to be greater than 700. Okay, so let's start with this limitation right here first. If it's going to be even, then it has to end in an even number. So it's got to end in either the 4 or the 6. So this last slot right here, there's two choices. Excuse me. Okay, so you have two choices for this last slot. It can either be a 4 or a 6. Okay. All right, now remember that you can't repeat digits, so whatever number we choose here can't get used again. So let's deal with this greater than 700. If you've got to be greater than 700, then this first number has to be a 7. Because obviously if you start with any of these other numbers, you're not going to be greater than 700. So there's only one choice here, and that's this number has to be a 7. Okay, so so we have 1 times something else, times this 2. So we got to think about this middle number here. So if we choose either a 4 or 6 for this location, so let's just say we choose a 4, then the 6 now becomes available to be chosen here. If we had chosen a 6 in this last slot, then the 4 now becomes available to be chosen here. Okay, the 7 can't be chosen because we've already chosen it here in this first position, so that one's off the list. But off of this remaining list, there's actually 3 of these numbers that could be chosen right here. And that's the 3, the 5, and then either the 4 or the 6, depending on which one wasn't chosen right here. Okay, so you essentially have 1 times 3 times 2 in order to get this desired. This is your desired situation right here, that you have something that is even and something that is greater than 700. Okay, so the probability of this event, our desired situation is 1 times 3 times 2 in the top. That's a 6. Okay, and then in the bottom, we have to think about what are the total possible number of 3-digit numbers that we can create with these digits. Okay, well, if you think about it, if you just have a 3-digit number, and remember that we're not repeating, so I have 5 choices here for this first slot. You can choose any of these 5 numbers, 3, 4, 5, 6, and 7. I have 4 choices here for this next slot, and I have 3 choices here for the last slot. So that's 20 times 3 is 60, so when you reduce this, you get 1/10. Okay, and just to make sure that this is clear, so this is the 7 that could go in this slot. That's why I have a 1 here, so that's one choice. The 3 here is going to be either the 3, the 5, and then either the 4 or 6. That's where I'm getting 3 there. It's got to be the 4 or 6 here, so you got 2 to choose from there. Okay, so that's what's giving us the numerator of a 6. And the denominator, when you're thinking about the total number of ways that it's possible to get a 3-digit number that doesn't repeat using these numbers, you have 5 choices to start with. Once you've once you've used that number, you can't use it again. So you've got 4 choices left for this number and 3 for that number. So that's where I'm getting desired, which is 6, over the total, which is 60, and that reduces to be 1/10.